Hey everybody. We'll wait about a minute for people to trickle in, and then we'll get started. Okay, so it's 2:01. We're going to go ahead and get started. My name is Andy Robbins, and you're here in the SpecterOps webinar week. Yesterday, we heard from Richie Cyrus, who gave a really good talk about hunting from home. You can see the recording of that if you go to either Richie or the SpecterOps Twitter feed. Go to the Zoom link and then just go to the registration thing, and you'll be able to watch Richie's great talk. Today, I'm going to be talking about everything you always wanted to know about Bloodhound, but were afraid to ask. And then tomorrow, Will Schroeder will be talking about Kerber roasting revisited. A couple of housekeeping items. There's going to be Q&A at the very end. There is a Q&A function in the Zoom application, so please submit your questions there. We'll try to get to as many of those as we can, and any questions we can't get to on the webinar, we'll follow up with an email or maybe in the Bloodhound Slack. This webinar is being recorded, so if you need to drop off, you can watch the recording later, or you can share the recording with your colleagues later as well. And with that, let's go ahead and dive in. Let's get started. So first of all, just to kind of give some context of where we're coming from here. SpecterOps has three major service lines. So adversary simulation, which is what it sounds like. So that team emulates adversaries in a network, and they do that to test our clients' detection capabilities, identify and exploit attack paths, etc. They also do like internal red team development for our clients. The adversary detection team, they perform threat hunting engagements, and they also help our clients build up their own threat hunting programs and teams internally. I come from the adversary resilience team. So the adversary resilience team, we use Bloodhound, and we use some custom tooling that we've developed internally to help our clients quantify, understand, and eliminate all critical attack paths and dramatically improve their AD security posture. And so we do that in a way that, we're not telling them just re-architect your entire Active Directory. We're giving them like very prescriptive, precise, actionable, and within reach recommendations. So that's always our objective with those engagements. Okay. So here are the questions that we're going to look at over the course of this webinar. First of all, is Bloodhound safe to run? Am I going to kill a domain controller? Am I going to kill the network? Am I going to kill computers that are joined to the domain by running this thing? Why isn't Bloodhound rendering the results of my query? This is a very common question. So we'll look at the architecture of that and how you can troubleshoot why the tool may not be rendering your query results. And then finally, another very common question we get is, how do I collect data from a non-domain join machine? So we'll look at that, and I'll show you exactly how we recommend going through that. At the end, we'll have open Q&A, so please feel free to ask questions using the Q&A function in the Zoom application. All right, is Bloodhound safe to run? Short answer, yes. Now, obviously, I'm biased as one of the co-authors of the tool. Based on my own experience, based on the experience of the SpecterOps team, based on experience of most of the Bloodhound users that we hear from, there's never an issue with system stability on the endpoint you scan from, on domain controllers and the network, and endpoints that are joined to Active Directory. But let's see if we can be a little more empirical about this as opposed to me just kind of spouting off my opinion. So let's talk a little bit about how Sharpound is built. So Sharpound is actually built on top of Windows native APIs that we'll list out here in a second. But you know, Sharpound isn't doing any kind of like, it's not taking advantage of any exploits. It's not running any weird code. It's literally importing namespaces from Microsoft authored C# namespaces, and it's using functions within those namespaces the exact way that they're designed to be used, and the exact way that systems on the other end of those expect them to be used as well. So for Ldap, for getting information from Active Directory, Sharpound uses the system.directoryservices.protocols namespace, which is authored by Microsoft, of course. And we use functions within that namespace to get information from domain controller. And so 99.9% of the traffic that Sharpound generates from the system you're collecting information on to the domain controller in particular is Ldap. So as we'll see in the lab, if you feel comfortable running net users whack domain, you can feel comfortable running Sharpound. And then for querying information from domain joint servers and workstations, Sharpound uses Win32 API functions to get information from those systems remotely. So we use these four functions: net session enum, net workstation user enum, net workstation get info, and net local group get members. So you can look up all these on TechNet, and you can see exactly how they work. All right, so that's all well and good, but what about actual brass tacks about, you know, what kind of load you can expect when you're actually running Sharpound? So let's create a test domain. So I did this already. I used Bad Blood to create a test domain, and that test domain has 54,000 user objects. It has 20,000 group objects, and it has 50,000 computer objects. Not 50,000 computers. I didn't stand up a lab that large, but 50,000 computer objects in the directory. If you want to see more about Bad Blood, you can see it on that GitHub repo there. So let's measure resource consumption, and so let's try to be kind of empirical and see exactly like what's happening on the systems affected by Sharpound. So we're going to look at three systems in particular. We're going to look at the domain controller. We're going to look at the system where Sharpound is running, and we're also going to look on a domain joined server that gets scanned by Sharpound, and we'll see what the impact is on the resources on all three of these machines. Okay, we're going to look at CPU utilization on each of those, and we're also going to look at RAM utilization on each of those. All right, let's do it. So this is actually the very first time that I'm using a live lab in a talk. I'm not using videos, so if things go wrong, don't be surprised. So on this system over here on the right, we have our domain controller, and we're using Resource Monitor to see CPU utilization, disk utilization, network utilization, and then we can also see memory utilization as well on this tab. And when the domain controller is serving all these Ldap requests and it's doing all this labor that Sharpound is asking it to do, that labor and that work is performed by LSAS on the DC. So we're gonna have a check mark on LSAS, which will cause a color-coded line here in Resource Monitor that will show exactly how much CPU, for example, LSAS is using. And then on the left-hand side, we have a computer that is joined to the domain, where we are running as the Jeff Dimmick user. And so this system is Win10001, okay? And then in this directory, we already have sharpound.exe. And we actually already have a Sharpound cache file, that .bin file. I'm actually gonna delete that file so we can see how Sharpound performs without that cache file being already present. Okay, so let's delete that delete that cache file. And so now we just have Sharpound. So let's run Sharpound, and let's do the DC only collection method. All right, now keep an eye on this pane right here. So this is the CPU utilization on the DC. Let's run Sharpound. And if you see the spinning circle of death, that's because my OSX system is trying to catch up. So on the DC, we see an initial spike on the CPU where the CPU utilization goes up. I didn't see what it said on this column right here, but it's probably something like 65%. And then as Sharpound is chugging along doing its thing, the CPU utilization is going to taper off. It's going to plateau off, whatever you want to say, and it's going to hover around 5 to 10% CPU until it's finally finished. So we'll let Sharpound keep running, and we'll also see like just how quickly Sharpound runs in an environment that's that large. I think I can already see that OSX is not having a fun time running all these VMs at the same time. So let's let this keep running for a second, and then we'll keep going with the presentation. We've got a lot of questions coming in on the Q&A tab, so keep those coming. We're going to get to as many of those questions as we can before we wrap up. Okay, so I'm going to let Sharpound keep going. And in the meantime, as OSX tries to keep up with running all these VMs, we're going to go back into the deck, and then we'll come back to Sharpound once that's finished. So earlier, running this, I was able to see that on the domain controller, there was an initial spike of about 37% CPU, and then about 5% CPU utilization for the remainder of the time Sharpound was running. Running this before Sharpound finished in about 2 minutes on collecting all the information from the DC. After Sharpound is done, we're going to go back in and we're going to run net users whack domain, and we're going to compare, and we're going to see how much CPU utilization there is from running that command and compare that to Sharpound. The RAM utilization on the DC, there's no change. There's no change whatsoever as far as I could tell. I didn't see LSAS increase its memory utilization at all, or any other process running on DC. The system that's actually running Sharpound, so the VM that I have there, it's got 4 cores assigned to it, and it has 4 gigs of RAM assigned to it as well. So the CPU running the VM running Sharpound, the CPU utilization averages about 60% as that data collection is running. And the RAM utilization averages about 220 megabytes. So especially if you compare that to our original data collector, that's very, very minimal RAM utilization. What we'll also see once Sharpound is finished scanning from the DC is a domain join system scanned by Sharpound. There's no noticeable increase on either CPU or RAM. Remember that there's only a handful of API functions that are being called against the domain joined endpoints. So these 4 here at the very bottom. What I would say, in my personal opinion, the load, so to say, on each endpoint is very similar to if you did like net view against one of those systems. So very, very light on the domain join systems. Let's go back into our lab and see if we're done here. We are. So that finished in about 4 minutes. I think the reason for the difference is because I've got so many resources assigned to so many VMs, and OSX is not very happy about that. Okay, Once Sharpound is done compressing this data and we get back to our console, we'll run net users whack domain, and we'll compare the CPU utilization to what we were seeing with Sharpound. So that's done. Okay, so now keep an eye again on the LSAS process. Check out the CPU column for how much CPU LSAS is using for this request. And again, we'll wait for OS X to keep up or to catch up. So we'll do net users whack domain. So I think the highest I saw it go was about 15%. And as the DC is getting ready to send that data back, there's still some CPU utilization, and then it all will fall back to the network as the DC is feeding that information back to the endpoint that requested that data. At this point, the data is on the system. It's just the Windows console is printing the information now, and this is as fast as it will print that out. But the work on the DC is done. All the work now is on the console, the PowerShell console. Okay, so let's look again, finally, and I will try to spin up another VM, and we'll see if we can run Sharpound against this VM in particular. So I will start this VM, and as we're waiting for that, let's stay here. Let's stay here in the lab, and then we'll run Sharpound against this computer here in particular. Okay, so this computer's up. And believe it or not, we're gonna try to run one more VM before we're done. So on this computer where we ran Sharpound before, we have a computers.txt file. And in that computers.txt file, we have this one line right here. So we have the fully qualified name for Win 2016-001, which is this computer here. So if we do like net view on that computer, we'll see there's no entries in the list. And if we try to do like, if we try to dir $, for example, we would get access denied because Jeff's not an admin on the system. He probably shouldn't be an admin anywhere if you've ever met the guy. So there's no change in resource utilization on this system when we run net view, and that's exactly what you would expect. But what if we run Sharpound against that computer? So again, after waiting for OS X to keep up or to catch up, then we will run Sharpound against this computer in particular. And we're going to do that with a flag called computer file. So computer file lets us pass a parameter here, which is going to be a text file that is line separated computer names, just like you saw when I did get content on that. And then we'll do computer only. So this is going to attempt to do the local group collection and session collection from Win 2016-001. And then we'll do the -- verbose flag on there as well. I always used to think OS X was a really good VM host. No, I'm not so sure. What did I do wrong here? Oops. This should be collection method, computer only. Maybe not. This is why you don't do live demos. Oh, it's because I'm running the binary, not the PowerShell version. Okay, so keep an eye on this computer Win 2016-001 on the resources here. On the process that's actually serving this information back, there's no difference. Let's do that again. I actually think that this little spike right here is a little anomaly. Yeah, so when we run this against a remote endpoint, there's no difference whatsoever on the resources on the system. So you're not going to introduce any instability on systems that are joined to the domain. You're not going to introduce any instability on the domain controller. You're not going to really introduce any instability on the system running Sharpound either. I'm going to go ahead and pause this guy. because the next demo that we're going to do in here is actually going to be running from a different system that's not joined to the domain. Okay, let's continue on. So another question, why isn't Bloodhound rendering my query, or why isn't it rendering the results of my query? Or another way that we've heard people ask this question based on, you know, what they're experiencing is, how do I improve the performance of Neo4j or Bloodhound? So the short answer is it depends. It depends on what the choke point is in the whole architecture of the tool. So when you click on basically any query in the Bloodhound GUI, you'll see in the lower left, you'll see the little animated dog doing his little thing, and you'll see a status message above the little dog that tells you what's going on. So in plain English, and to kind of translate a little bit, like what's happening with each of these, when you see querying database, the Bloodhound interface is waiting for Neo4j to finish running the query, and it is also waiting for the streaming process to finish. So the results of the query need to stream back to the process where the GUI is running. And so that can take time depending on how much information is coming back and whether you're running this locally or if you're running it remotely. Once that's done, then the status message will change to processing data. At this point, Neo4j is done, and now all the work is on the GUI. So processing data, this is the node folding logic. This is a step that is necessary for us to do to try to save some of the labor in the next step. So when after the node folding logic is done, then Linkurious takes over. And that's when you see this message that says initial layout. This is where Linkurious is calculating the layout for the graph. So all the work on Neo4j is done. All the work on the node folding logic is done. Now all the work is on Linkurious. 9 times out of 10, or maybe even 99 times out of 100, Linkurious is the biggest choke point. So if you're stuck where you see this initial layout message, the performance issue is with Linkurious. Why is this? So Bloodhound is a graphical tool, obviously, and the graph rendering work, it needs to be done by a library that we use, and that library is called Linkurious. So graph rendering libraries basically come in 2 flavors. One is CPU rendering, and the other is GPU rendering. If you know anything about graphics, you know that GPU rendering is orders and orders of magnitude faster than CPU rendering is or ever will be. Those 2 flavors of graph rendering libraries I referred you to, the CPU rendering libraries, they are free and open source. The GPU rendering libraries, they are all commercial. So because Bloodhound is a free and open source tool, we are bound to using a free and open source graph rendering library. And the one that we chose is Linkurious. So because of the graphical element of the GUI, and because we're bound to this open source graph rendering library, this is where a lot of choke point happens, is in this step right here where it says initial layout. However, once that's finally done, then the status message will change to done, your graph is rendered, and you're good. Okay, let's look at one of the most common queries that somebody may want to do. So you're in the Bloodhound interface and you're looking at the members of the domain admins group, and any node in the GUI you can right click on and get this menu. And one of the more interesting queries to run is shortest paths to here. Okay, well, let's do this. Let's have our query debug mode on. So we've got that on, and let's move this so I can close that. So when I have query debug mode on, any query I run, the actual raw query that Bloodhound is sending to Neo4j is going to render down here, so we can see exactly what the interface is asking Neo4j to do. So let's right click on the domain admins node, and keep in mind, this database has 54,000 users, 50,000 computers, 20,000 groups, and it has 3.5 million relationships, 3.3 million ACLs, thanks to the bad blood tool. Let's right click. Let's do shortest paths to here, and let's wait. So from doing this earlier, I know that this querying database step is going to take about 30 seconds to finish. Then the interface is going to go on to the processing data step where the node folding logic happens. Currently, that's not going to finish. We made a change that has been committed up before we went live on this webinar, but I didn't have a chance to pull down. But when the processing data step, if it has a lot of nodes that it needs to chew through to calculate, it's going to give you a warning, and it's going to tell you, hey, this is a lot of nodes. It's probably going to take a long time to finish. So here we are. We're now at the processing data step. So this is the node folding logic. We're going to change this so that if you have a lot of nodes that need to go through that node folding calculation, you're going to get a warning. It's going to ask you, do you want to proceed, yes or no? If you say yes, then it will proceed and it will start processing the data. If you say no, it will bail out, and it will also tell you, this is the number of nodes that you're asking me to calculate. So over time, you should get a good feeling of how many nodes are reasonable for your system to actually churn through for this step. So this is not going to finish in the remainder of the time that we have here. So I'm going to close Bloodhound. That's going to kill, obviously, that process, and it's going to kill that job. I'm going to reopen it, and I'm going to show you how I would recommend that you troubleshoot this if you experience this yourself in the future. So the objective, I would say, is to figure out two things. I would say, where's the choke point, and what can we do about that without having to recode the entire GUI or build from like D3 or something like that. So the query that Bloodhound ran, if you looked in the raw query bar, this is actually the query that Bloodhound ran right here. So in your Neo4j console, which if you're running Neo4j locally is at localhost on port 7474, you can very simply just copy and paste the query from the raw query bar and then paste it in here. And the original query says return P. So return all the paths, or return all the results of shortest path, which is assigned this variable here called P. What I'm going to do instead is I'm just going to return the count. So I'm going to return the count of P. So how many paths are coming back? How many paths is Neo4j sending back to the Bloodhound GUI for the GUI to attempt to render? So after this finishes, which should take about 16 or 17 seconds, we'll see how many paths there are that Bloodhound is going to be tasked with rendering. Okay, there are 104,684 paths that Neo4j returned from this query. That took 25 seconds for it to run. It runs faster if I'm not running 9 VMs simultaneously. So this is too many. This is never going to render. Linkurious is never going to be able to calculate the layout for this number of paths. Regardless of whatever node folding logic we do, it's highly unlikely that you will ever be able to render this in the GUI today. But what we can do is we can limit how many of those paths are coming back. And so we can still see what some of the data looks like. We can't see what all the data looks like, but we can see what some of it looks like. And the way we do that is pretty simple. We're going to change this query, and we're going to add a little something at the very end. So instead of it ending at return all the paths, instead of it ending like that, we're going to have it end with the limit verb. And we're going to say, I only want to show the first 100 paths that come back. So let's copy that from the Neo4j web console, and then let's paste that in here into the Bloodhound GUI in the raw query bar. We will hit enter, and then now we have some data. If you want to expand on this, just go to the very end of your query here, and let's increase it to 1,000. Why not? That doesn't look any different, and the reason for that is because the node folding logic took over, and it folded a lot of users into this domain users node right here. So if you look closely here, you can see there's a little glyph right here on the domain users node. It says 947. That actually means that there are 947 user nodes that are not being drawn. They're actually folded in here. If you want to try to expand that out, which, hey, why don't we do it? You can right click on the node, and you can come all the way down here to say expand, and then the Bloodhound GUI will attempt to render that for you. And so it did. Again, all that work is on Linkurious. So there's going to be a limit there as to how many you can reasonably render. But the end result is that you don't necessarily need to be out of options if the Bloodhound GUI can't render the results of that query. You can just hone it down so that you're returning a smaller number of paths. And hopefully, if your objective is, for example, maybe to educate your customer about the attack paths that exist in the network, hopefully you can use this to demonstrate that to them. Okay, so let's continue on. Last question that we're going to go into that's kind of prepared before we go into open Q&A. How do I run Sharpound from a system that is not joined to the domain? And so the answer is it all comes back to DNS. So think about when you're resolving like an NT4 name, or if you're resolving a host name, or you're trying to resolve anything really, like if you're trying to resolve a domain short name to the domain fully qualified name, that information has to come from DNS. And 99 times out of 100, that DNS is managed by the domain controllers. Sharpound does a lot of resolution, a lot of name resolution, a lot of DNS resolution. It needs to be able to communicate to the domain controller over DNS. And then also, in order to get yourself into a domain authenticated context, you also need to think about DNS to get into that domain authenticated context. So let's look at how we can do this in a 4-step process. So first, we're going to set the system DNS server to the IP of a domain controller. Then we'll launch CMD as a domain authenticated principal. We'll confirm our domain connectivity and make sure that we're actually, authenticated to the domain. We can talk to the domain. And then we'll run Sharpound. Easy as that. So let's see how that works. Let's see if my lab doesn't crash. So on this VM, we have a system that is not joined to the domain. And then on my domain controller, we will bring this bad boy back up, and we'll see what his IP address is. All right. So on this system right here, I'm running as the Waldo user, and it's just a random, generated VMware, hostname. Are we joined to a domain? Let's try net accounts whack domain. No. So it's saying we're going to look for a domain controller at the domain work group. No. So this computer is in a work group. It's not in a domain. If we do like net users whack domain, no, you're not in a domain. You're in a work group. Okay. Well, our first step was we need to set the DNS server on this system to be the IP address of the domain controller. So in Windows, there's 1,000 ways to do that. I'll show you how to do it in the GUI. So instead of obtaining server automatically, we'll use a specific DNS server, and that's going to be the IP address of my domain controller over here. So it's 192.168.231.129. Okay. So now we should have DNS resolution, and let's try one more thing. Let's see if we can see the sysvol on the domain controller. So we'll try net view against the domain controller, and we get access denied. So this is because we do not have valid domain authentication. So this user Waldo is not a principal in the domain, in the Contoso domain. So we need to get into a domain authenticated context. You need a username and a password for that. So get that from phishing, get that from Kerber roasting, get that however you want to get it. But you must have a username and password for this next step for a user that's in that domain. We're gonna continue to abuse Jeff Dimmick, just as all good people should, and we're gonna use the command run as. Run as lets you run a process as a different user, and there's a very important flag that you need to use here. And that is the /net only flag. Net only means that when you launch this process as a different user, that process is going to authenticate as that user only when it's doing so against remote systems. It will not impersonate that user when you are authenticating locally. The reason for that is if you try to authenticate as Jeff Dimmick locally on this system has no clue who Jeff is. So you must use this /net only flag so that the system doesn't try to authenticate Jeff locally. Our user is Contoso Jeff Dimmick. And we're going to run cmd.exe. Then we will enter Jeff's password. And now we have a CMD running as Jeff Dimmick. If we run who am I, we can still see that locally we are Waldo. We're not authenticating as Jeff locally, but if we try to now view the contents of the sysvol, it will authenticate as Jeff to the DC, and now we can see the sysvol. So we have successful domain authentication against the DC. So we've validated that we are authenticated to the domain. And so now let's go into ctemp where I have Sharpound here. Let's delete the cache file, and let's delete the zip file. So now we just have Sharpound. Okay, let's run sharpound.exe, and we're going to specify the domain that we want to collect from. Otherwise, eventually Sharpound will try to do enumeration against the workgroup domain. We don't want that to happen. We just want to constrain ourselves to the Contoso domain. So that domain is contoso.local. And we'll just do DC only collection, for example. We'll hit enter and we'll let Sharpound run. And so it's going to take about 2 minutes for this to finish. I'm trying to think if there's anything else I can show you in the meantime. I guess you can look if you want on the domain controller. You can look at the CPU utilization. So now that OS X isn't pausing this VM every 10 seconds, you can see what the CPU utilization looks like on the domain controller, where it's serving up the content that Sharpound is asking for, or it's doing all the work that Sharpound is asking it to do. So once this finishes, it's going to be the exact same process as before. So there will be a zip file in this same directory. And then that zip file, you can just drag and drop into the Bloodhound GUI, and then find your attack path and execute it. Okay, so I think that illustrates that. So let's go back into the deck, and that finishes up the prepared questions. So I'm going to put this slide up where we have the URL where you can go get Bloodhound if you don't have it already. And then also the URL here for the Bloodhound Slack if you want to join the Slack and chat with us. Otherwise, I'm going to start looking at the Q&A. I don't know if Rohan had a chance to get on and if he already selected some questions to answer.
I did, Andy.
Oh yeah, okay. Why don't you go ahead and then I'll mark some that I'll answer.
Perfect. So the first question we have here is, will Bloodhound still work with the new Ldap signing requirements Microsoft is pushing? As far as I know, yes, it will. We actually sign and seal every Ldap request by default. So it should be fully compatible with those new changes. If not, we will definitely do our best to update it whenever we run into those problems. So the next question we have is, as red teamers, how can we run the ingesters in stealth mode? That's a very, very dynamic question because that's going to depend heavily on what the people you're targeting are able to detect. If they have something like NetFlow analytics, there's going to be no real way to avoid it because network flow is a big part of Sharpound because of just the scale of data that it's pulling. That being said, we usually use a collection method DC only, which pretty much only pulls Ldap data and only touches domain controllers. And in general, that's a pretty good way to stay low while still collecting a really good amount of data. There's also the stealth flag if you want to try that as well, which limits how many systems are targeted by session collection, and it grabs local group data from GPO instead. Another question we got was, how's the decision on which ACEs or ACLs are collected from which domain objects? Is it always the same set? The set of ACLs that we collect correspond to exploitable attacks that we have found or other people in the community have found. So anything that we know is an exploitable ACE, we collect. But yes, that is a hard-coded list of ACEs. We actually have a few questions that are very, very similar here. I'll just paraphrase here. Does the user need to be an admin or can a normal user run Bloodhound? And will that change what the results are? The answer is yes, you can run it as a normal user or an admin. However, an admin is going to get a significantly better chunk of data, especially in environments where Windows 10 is the normal deployment. After Windows 10 Anniversary Edition, Microsoft actually locked down the ACLs on the Samurai PC service so that only admins can collect that data remotely. So if you're running Windows 10, you will need to do admin collection to get a good set of data. A normal user can still run this and they'll be able to pull pretty much everything from Ldap normally because there are no restrictions on that. But the local computer data will be much more limited. We also have, go ahead, Andy.
Go ahead. There's two questions I'll answer after you're done.
Okay. We also have the logged on collection method, and that actually does privileged data collection from computers. So that's a separate collection method because it'll only work if you are an admin. However, the accuracy of data returned by that is orders of magnitude better than session collection. So if that's an option for you, I would always suggest it.
There's two questions that are kind of the same. So to paraphrase, Sharpound keeps getting caught by antivirus. Any suggestions? So unfortunately, Sharpound does get flagged by antivirus. It is a red team tool, so that's not to be unexpected. There are several different things that you can do to evade that detection in like descending order of complexity. So I would say that probably the most complex would be clone the GitHub repo and then modify the source code in Sharpound so that you get a different signature. So you get a different hash for the binary. Change the publisher information, change the other meta information about the binary, and you'll be able to evade just a very easy, brittle signature-based detections. Otherwise, probably the second least complex, I would say, and this is all a matter of perspective, would be just run Sharpound completely in memory and never put it on disk. Never give antivirus a chance to scan it when it's sitting on disk. So if you're using Cobalt Strike, for example, and I believe Covenant has this capability as well, you can actually run a .NET assembly without ever putting that assembly on disk. So in Beacon, it's called execute assembly. I don't know what it's called in Covenant. I think it's called a run assembly. That will give AV no opportunity whatsoever to scan it when it's on disk. The other way that you could evade is, so I ran Sharpound from a system that was not joined to the domain. If you do it that way, if you run Sharpound on a system that you have total control of, that is not on the domain, that's not getting antivirus from GPO or SCCM or whatever else, then there's not going to be any AV on there at all. So I think those three different ways you can use to evade AV. Otherwise, you can look at probably things like Donut, I think, or just in general, just look at like other like AV bypass methodologies that are out there. There is a bypasses channel in the Bloodhound Slack. You can chat about AV bypasses there. Otherwise, I believe there are a lot of resources out there that you can look at for evading antivirus just generically.
I can take the next question, Andy.
Oh, go ahead.
There's a question here. Is there any difference between running sharpound.exe or sharpound.ps1? Is there a benefit in a way or another? The PS1 version of Sharpound is actually literally the exe base64 compiled and loaded into memory by PowerShell. There is no difference between the two. If you have a choice, I would always suggest using the exe simply because if there is any errors or anything like that, it's a lot easier to debug an exe than it is assembly loaded in memory. But otherwise, there's no difference whatsoever. Another question we have here is, as a defender, there are several segments in my network. Is there any way to know how many hosts are unreachable due to a firewall blocking port 445? Actually, in Sharpound 3.0, we added a new flag called dump computer status. And if you use that, it will actually output a CSV file, which will tell you every time it tries to connect to a computer for anything, if it succeeds or if it fails and why it failed. So that'll actually give you a really good way to debug what is succeeding and what is failing.
Here's a question. So this says, would it be possible to get more information on bad blood? Yeah, so there's a link on the slide where I mentioned bad blood, where you can see the GitHub URL for bad blood. There it is right there at the bottom of that page. So go to that URL, and that's a good place to start with looking at bad blood. And then David also has a couple of blog posts written, or maybe more, about bad blood. So you can see how it works, why it was created, how to use it, all that kind of good info.
Another question here is, are there any ingesters like Sharpound compatible with Bloodhound? As far as I know, the only one is bloodhound.py, which is written by Darkion. And I'm not entirely sure if it's fully up to date with Sharpound 3. I believe it is. That's the only other ingester that I know of at this time. Here's a quick question here. I had an engagement a few months ago where they had Javelin sending me bogus data. I could spot the difference between real and fake data because of bad implementation. Is there a way to selectively remove data? Any edge or node can be right-clicked and deleted from the UI. If you want to do kind of a bulk thing, you'll have to use a Cypher for that. And there's quite a few references out there on learning Cypher. I don't think we really have time to cover them right now, but that's definitely a question that could be asked in the Bloodhound Slack channel.
We can probably send that out in the follow-up email as well, like a list of Cypher learning resources.
Sure. Is Bloodhound 3 compatible with Neo4j version 4? Yes, it is. Go ahead.
Here's a quick question. So this question says, do you have any new tools similar to Power BI analytics? Justin, are you on the webinar?
I am. What's up?
So the question is, do you have any new tools similar to Power BI analytics? I think so the answer is yes. So and Justin, just like stop me if I, go too far, but I tell you what, we'll answer that question to you directly in a follow-up.
The next question we have is any known limitations of Neo4j from the amount of nodes perspective? The only limitation I know of is there's a 32 billion node limit and a 32 billion relationship limit on Neo4j community. I don't think you're ever going to run up against that problem when it comes to any Active Directory environment. I believe that's far outside the realm of the max Active Directory size anyway. So
yeah,
I wouldn't worry about that as far as Bloodhound.
Yeah, and just to add to what Rohan just said, regardless of how large the database is, if you're doing node to node pathfinding, that is always going to run in a reasonable amount of time. So regardless of how long the attack path is, regardless of how many nodes there are, if you start, for example, from this node and you go to this node over here as the ending node, that information will always finish, at least in the Neo4j side, very quickly. So you don't need to worry about getting to the limit in nodes and relationships in Neo4j, like Rohan said.
A question here is, what's a good strategy for doing Sharpound collections in large domains and organizations? Generally speaking, when Andy and I do this, we don't even really worry about it. As this presentation is kind of meant to showcase, Sharpound is really just doing stuff that your domain expects to happen. If you want to pare it down, you could start DC only and just collect Ldap data, and then move around to doing the computers. But in our experience, we've never had to do anything along those lines. We usually just do like a full data collection to start with, and we've never had any problems. I believe this question is, in your opinion, is network traffic caused by Bloodhound with the stealth flag easy to catch by the blue team? The answer to this is, again, it completely depends on what the blue team is looking for. We've frequently said that Netflow Analytics is a super easy way to actually catch Bloodhound, but the number of mature organizations that actually have robust Netflow Analytics is so low that we've run into it maybe once or twice tops. So it's really a question of what are you looking for, and does that cover the use case that Bloodhound is going to hit?
Here's a question I can answer real quick. So the question is, what is the largest network that you've tested, and how long did it take? So the network that actually inspired the creation of Bloodhound had approximately 200 Active Directory domains in a giant forest, and it had something like 300,000 endpoints. And that was back in 2016, and that took about 48 hours for the data collection to finish. Since then, with the improvements that Rohan has made with Sharpound, now the largest network that we've run Sharpound in is approximately 600,000 endpoints. And the data collection process for that finishes in about 2 hours max, I would say, when we use like the thread flag and like the skip ping timeout flag and other flags like that. So 600,000 endpoints in about 2 hours to collect all the data from the remote endpoints.
We have another question here. Is in some engagements I've seen that Bloodhound finds has session edge between a computer with a user account and it's only showing a SID. That generally means, especially in the case that you're talking about where the SID is not the domain SID or the parent domain SID, that the logic that tries to resolve local user sessions failed, and it added a local user session to the database. We try our best to kind of filter those out, but it's kind of difficult a lot of times. A lot of session collection is kind of best guess because of the limited amount of data that we get from the NetSession enum API query. So occasionally there will be some like weird inconsistencies, but we do, trust me when I say we try very, very hard to keep that from happening.
One of the questions here is, how deep into Bloodhound usage does the Red Team Ops course go into? I believe there is, you know, Bloodhound usage that is taught in the Red Team Operations course. As far as how in depth it goes, you're not going to learn about like Cypher in that, and at least as far as I know, the data collection element in the Red Team Operations course is actually done for you. So you'll learn how to use the GUI and you'll learn how to do like basic pathfinding and things like that. But I'm not sure that I would say you're going to get like a very, very like in-depth like master's course in Bloodhound, for example, from the Red Team Ops course. The Red Team Ops course is way more about like teaching you the TTPs, like the lateral movement TTPs, persistence TTPs, and like how defenders can hone in on those things and how you can get around those detections and things like that. So that course goes way more in depth on how to be a more effective Red Team operator from that perspective. Here's a question I can answer. So this says, any suggestions on creating statistics for Bloodhound? My thoughts now are making my own custom queries. So we have a blog series out there called the Adversary Resilience Methodology, and a companion tool in that blog series is this Power BI workbook. And that Power BI workbook will give you kind of a starting point in building out your own statistics using Power BI and interfacing with Neo4j. And it's kind of pre-built with some interesting statistics already, like the largest Active Directory groups in descending order and things like that. And Power BI does a really good job of rendering that as a good looking bar chart. So if you look for that series, and then we can also include that in the follow-up email, so it's easy to find. I would say that's a good starting point for looking at how you can create your own statistics for Bloodhound. Here's another question. So this says, to get that level of performance from Sharpound, did you have EDR controls turned off? No. The organization I referred to earlier that had 600,000 endpoints and we did collection in 2 hours, no security controls disabled for that, including the system that we were doing data collection from. We actually could not get any security controls turned off. So as far as I know, as far as I understand, I don't believe EDR would have any performance impact on Sharpound or affect Sharpound's ability to collect data at that speed. So we have a lot more really good questions. We are going to go ahead and wrap up. Any questions we didn't get to, we're going to try our best to answer in a follow-up email or answer those questions directly. I want to thank you very much for attending today's webinar. Tomorrow, Will Schroeder is going to be talking about Kerber roasting. I would highly recommend that you attend that talk. And if you want any more information about SpecterOps, the company, our services that we offer, you can find us on the internet, SpecterOps.io, on Twitter, @SpecterOps. And the best way to get a hold of us, email us at info@SpecterOps.io with any other questions you might have. Thank you very much. Have a good day.